Hey there, liberal arts. Welcome to Distance Learning Math. You don't get to see me anymore, but you still get to hear my lovely, luscious, beautiful voice. I'm going to talk you through kind of the expectation for this. Now, first thing I want to point out is I'm here on my dashboard, and you're not going to click on, the first period liberal arts math or fifth period liberal arts math or whatever. You're going to be clicking on the Distance Learning Math. So I have one for my Algebra 1 class, and I have one for you guys. Now, this liberal arts math class, this distance learning math class, it's for all the liberal arts students in the school. And so when you click on it, you'll see, welcome page, all that stuff. It kind of talks you through Canvas if you don't know how Canvas works. But over here on the left, you'll see modules. And you'll click on modules. It might be going a little slow right now because a lot of people are logged in. So bear with me on that. So we'll wait for it to load. So modules, you have a welcome module, you have introduction. This just tells you how to use Canvas if you don't already know how to use Canvas. But here we go, week 1. This is what we'll be doing this week. You guys can do it all in one day. You can do it one today, one tomorrow, or I don't know how you want to do it. Or just do it all like Thursday or Friday. But this is what you have to get done this week. All right, week 2, this is what you'll have to have done next week. Your attendance is based on your completion of these weeks per week, essentially. So if you don't do any of this week, then you're not getting any attendance for this week. But I would assume that if you did this one and week 2 this week, that you'd have this week's attendance and next week's attendance accounted for. So you get the week attendance accounted for if you've got this stuff done by the end of the week, for at least week 1's worth, right? If you have week 2 done before next week is over, then you get week 2 attendance. Hopefully that makes sense. All right, week 1's pretty short. We have a checklist to look at and then just one section of work to do and one quiz to do. Now, at any time, if you have any questions, you can go hit the discussions tab and ask me a question there. So course questions, you can ask your question there and I will reply to it. There are certain hours I'll be on, certain hours I'm not on, and that'll be listed here. My Welcome to Distance Learning Liberal Arts Math class. But anyway, let's get back to the modules. But if you have questions, go ahead and throw them in there, and I'll be happy to see what I can do. All right, let's get into let's check the checklist real quick, and then we'll get into 2.01. Now, the checklist isn't really anything. I think it's just kind of what we're going to be doing over the next few weeks. So representing data, which I believe is the first task that we're going to do, 2.01, and then some of the stuff that we do over the next few weeks. Really just kind of a list of what's coming, right? Now, you'll notice here at the top where it says home, 1 of 1, page 1 of 1. That means there's really no other page here, but if it's like 1 of 5 or 1 of 6, you have to click these arrows to go through it to the next page. But what we'll do, that automatically takes me to the next page. Hold on a second. This is loading very slowly again. All right. What we'll do is, if there's no more page there, then at the bottom of the screen, there's a next button, and we could just click next. And that's going to take us to the 2.01 representing data section, which is here. So this is the 2.01. So we could have clicked on that. Let me show you again, just where it took us, right? It's taken us directly to this 2.01 representing data. So we're now on this page, looking at this together. If you hear my notifications in the background, don't mind that. All right. Again, it might take a second to load for you guys. I like to just kind of move my mouse around or scroll. It might help it load faster. So if you have any issues with that, just, be patient. All right, so 2.01, representing data. Our objectives here are representing real-world data with a dot plot. Use a data display to create a data display to create a data display of a different form. Okay, makes sense. Represent real-world data with a histogram. Choose an appropriate scale when displaying data. Interpret the scale and origin in graphs and data displays. A lot of fancy lingo there. By the way, we're kind of done with the geometry stuff, or we'll come back to geometry stuff later. But right now we're jumping straight into the statistics part of liberal arts. So if this seems kind of weird and new to you, I know we were just doing the geometry stuff. We were just doing, what did we do last? Like similarity, I think, triangle similarity, something like that. Yeah, this is still liberal arts, but we are jumping to statistics now. So you guys can read all this, data. Data is collected information about a given topic. Collecting data can help someone learn more about a particular topic and make conclusions, and so on. This is known as statistics. So you've got a process for statistics, form a question that can be answered by data, design, implement a plan. It's kind of like the scientific method, if you will. It's very sciencey based, but with less experiments and more data collecting. I guess it is kind of like an experiment, but an experiment in which you're collecting data. You're not necessarily seeing like chemical reactions or anything. It's just an experiment where you count data. Okay, and you can watch this little video here. That's nice. I'll leave that for you guys. But the first part, forming and designing a plan. So there are 2 tabs here. Step 1, form a question. Step 2, design, implement a plan. So you guys, again, we can read through this. Step 1, form a question that can be answered by data. So in the real world, we have, questions sometimes like, well, how does this work? Or what would happen if I changed this, right? That's kind of the beginning of the process. Our curiosity is spiked, and now we have to figure out a way to answer our question, right? But first part is making that question. So statistical questions specify populations and measurements of interest. The question should also anticipate answers based on the data that vary, but anticipate fixed answers. No randomness is involved. The answers to statistical questions will address the variation in data. Use probability statements and apply only to the population specified. Again, a lot of lingo, a lot of mumbo jumbo, but we'll get into what all that is. So, statistical and non-statistical questions. So let's understand what a good statistical question is. So a non-statistical question, does the pesticide raid harm butterflies? A good statistical question would be, what is the mortality rate in Coleus erythrithium? I'm not a science person. 1 hour after treatment with raid. Now here's a reason why these 2 questions are different. Why one is bad, one is good. The non-statistical question is too broad, right? Not measurable in our standards. It just says, does the pesticide raid harm butterflies? It doesn't answer the question of how it harms butterflies. It doesn't say how many butterflies are harmed. It's just simply a very broad question. It doesn't get into the details of the pesticide harming the butterflies. But the statistical question does. It emphasizes what's the mortality rate, 1 hour after treatment. So that way we can kind of measure how many of the butterflies are dying over the time period in which they are dying, right? So it's more specifically based something we can measure. Another non-statistical question, how tall is Shayla? And then a good one is, how tall are the students in my Algebra 1 class? So how tall is Shayla is not a good statistical question because it's too specific. It's only one person. It's only going to have one answer. There is no variation, nothing really to compare, if you will. But the good statistical question, how tall are the students in my Algebra 1 class? That's a good question because, let me silence all this stuff. There we go. Okay. That's a good question because it's not too specific, but it's not too broad either. It gives us variety. We're able to measure more students in the class, and then we can take an average of the data. We can see the mean of the data, right? We can analyze the results of that. It's not just one person that we can look at. We can compare people, And the last non-statistical, how many words are there in the sentence? Again, that's kind of too specific. Like the Shayla one, it's one answer. You can't compare it with anything. It's just a simple question. But the good version of that question is, how many words are there in each sentence of chapter 12? So it's like we can take all those different results. One sentence might have 10 words in it. One sentence might have 20 words in it, right? We can compare them. We can find means. We can find averages, right? We can look at those and compare them to each other versus just one sentence, which doesn't really have much to compare. It's just a simple answer. But that is how statistics works. Now, there are 2 types of data. There's categorical data. Some call this qualitative data as well, but here they call it categorical data. This is discrete, and it's things that can be separated into groups or categories. So, for example, the number of people that like certain sports. And, sports can be grouped into categories. So football, basketball, baseball, whatever, right? Those are that's categorical data. How many people like each sport? Then there's quantitative data, which is more measurable, more numerical. Both are fine. Nothing wrong with either of them. It's just two separate types of data. So quantitative data, like I said, is more numerical. It has a range of numerical values. That's very important, the word range of numerical values. It's not separated into categories. So, free throw percentages, we can kind of look at how many people average 45 to 55%, how many people average 56 to 65%, and so on, right? So that's quantitative data. It's more numerical or range of numerical values, like people between the ages of 20 and 30, or between the ages of 30 and 40, stuff like that. So you guys can try these. I'll let you answer them. The answers are down here below. Question 1, 2, and 3. It's just simply asking, is this information that you see, is this categorical or quantitative? So if you look at the first one, I'll do this one with you, right? We've got data separated into categories, right? Groups: compact, mid-size, full-size, luxury. This is not numerical information. These are categories. So this would be a categorical data, right? And you can see the answer right there. So you guys can try question 2 and question 3 and see if you're right, and see the answer and why that's the answer. Now, here's a very important thing. We're not going to hit next down here at the bottom right, because if you look back up here, we have 1 of 6. We have to go through these 6 slides because there's going to be more notes than what we just saw here. So we're going to click the arrows at the top next to home to go to the next page here. So page 2, analyzing and interpreting data. So now how do we read the data that we collect? One method is to use a dot plot. Dot plots are very, very simple, right? It kind of gives you directions how to make a dot plot here, but it is pretty straightforward. So here's an example of a dot plot. Take Wesley's class data and list it in order to identify the least and greatest values. So here, 8, 9, 10, 10, whatever, these are all basically, it looks like the number of dandelions, according to this picture, right? The number of dandelions the students have collected. So we have 8, we have 9, we have 10, 11, 12, and 13, right? So those numbers are listed on a dot plot. Now the dots themselves count how many are in that category. So let me screen snap this real quick so we can take a closer look at it. So there's only 1 dot for 8 dandelions, which means that out of all the data we've collected, there's only 1 that had 8 dandelions, right? Above 9, there are 2 dots, meaning that there were 2 9 dandelions, right? 2 groups of 9. 10 has 4 because guess what? There were 4 students that had 10 dandelions, right? 11 has 2 because 2 students had 11 dandelions, right? So on and so forth. So these dots here count how many people had that number of dandelions. Let's go back. Let's look at the next example, right? Categorical dot plots. So same idea. You can see the categories here are separated into blue, green, red, purple, black. We'll take another snapshot of this. Okay. There are, tallies of frequency is the same thing. It's just a different way of writing the same number. So there are 4 that are blue. There are 2 that are green, right? There are 2 that are red, and so on. So you have your categories listed: blue, green, red, purple, black. And then the dot plot is just counting how many blues there were, right? So since there are 4 blues, you have 4 dots above blue. Since there are 2 green, you have 2 dots above green, right? So on. So this way, this is a visual representation of the table we have here. The table has all this information listed, but this is a better picture for those visual learners. You can look at this picture and clearly see which ones are higher in frequency and lower in frequency. Like you can see that most people like purple just by looking at the picture. You don't have to look at the table. You can look at the picture and know that purple and blue are the 2 most popular, right? So pictures are a little easier to read than the table themselves. So it's nice to make those dot plots and to make those pictures. All right. Example 3, quantitative dot plots. Again, the same thing, right? In anatomy, Percy learned that the average resting heart rate is 60 to 100 beats per minute, right? And then he took the average heart rate of some people over 5 minutes. So, one person had 68 heartbeats per minute, 72 beats per minute, 78 beats per minute, and so on, right? He's got all his data recorded from all the people he recorded or measured the heartbeat of. And then he made a dot plot for it. So you can see on his dot plot, let's see if we can zoom into it, right? You can see the beats per minute listed at the bottom, and then the dots of how many people had that heartbeat or had that rate. So let's snip it so I can kind of annotate a little bit. So here, if I asked you guys how many people had, from Percy's experiment, how many people had 75 beats per minute, you can look at this, go, hey, 75 beats per minute, there are 2 dots, so clearly 2 people had 75 beats per minute, right? And you can go back to the original data and you'll see that out of all of this, there are 2 people with 75. There's one here and one at the very end as well. 2 people that had 75, right? 3 people had 68, for example. So, obviously, when you look at numbers listed like this, it's very confusing, but when you take all this information and put it into a picture, it's very easy to see and understand. But yes, there should be 68, or there should be 3 people with 68 beats per minute. So 1, 2, 3, right? And just taking that information, making it into a dot plot, just makes it easier for us to really see the results. All right, so you guys could probably try these as well. The following table displays how many computers are owned by different families in the same subdivision. So this is the number of computers. So maybe families who have 1 computer, 2 computer, 3 computer, or 4 computers. So from that dot plot, this would indicate to us that there are 3 families that have only 1 computer in their house. There's 1 family that has 2 computers in their house. There are 5 families that have 3 computers, and I can say that again because there are 5 dots above 3. And then there are 2 families that have 4 computers in their house, right? So that's, again, how we would read that dot plot. From this dot plot, I can immediately tell that purple is the overwhelming favorite. So let's see. Maddie surveyed people in the mall to find out their color preference. So yes, you can clearly see from the dot plot that most people liked purple. And if you want to count the number of dots, see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I believe that's 15. 15 dots above purple mean that 15 people chose purple as their favorite color, right? So you can clearly see what's the favorite and what are the least favorites. So the least favorite colors are orange, green, and blue. They all had only 4 people like them each. So again, dot plots are just easy ways of interpreting our data. Remember, we're not hitting next yet. We have to go back and we have to go to page 3 of this. Well, now, for me, it's not showing page 3, so that's kind of a complicated issue. Let's see here. This might be because the thing is going rather slow. So let me back up a second. Let me try and restart this. Yes, there is going to be some, I guess, lag or some problems with the program for first. But let's go to page 3. It says connection failed. So, yeah, there definitely seems to be some issues this morning with this. Let me try one more time. Connection failed. Okay. Well, guys, I'll end the video here. If I get more of it, I'll be able to answer your question. I believe it talks about histograms and stuff, so I'll find you guys next time. I wouldn't take the quiz just yet. I'd maybe wait to see if we can get this working. You might want to come back at a later time when there's less people on, and that might make this function a little bit easier. So, see you guys in the next one. Bye.